In 3.3 day 1, we're going to talk about some properties of logs, specifically inverse properties. I mentioned at the beginning of this section, beginning of this day, that the main reason logs exist is to provide a way to have an inverse for an exponential function. So logs and exponentials are inverses of each other, and so that will come out in what we do with the inverse properties here. So inverses basically undo each other. All right, so if I have 10 to the x and log base 10 of x, those are inverses of each other. If we combine them, if we put them together, compose them together, we got 10 to the log base 10 of x, then what comes out is just x, so they just cancel each other out. Very similar thing happens with this. If we have e to the x and ln x, since they both have the same base, they are inverses of each other because one's an exponential, one's a log, and so we put them together like this. E to the ln x gives us x. So the property just comes out as those are both x. It also works the opposite direction. With any base is what I meant to say. It also works with any other base besides e and 10. So if I have b to the x and log base b, no matter what that base is, if we compose the two together, b to the log base b of x, then out comes x. So in this case, if we've got e to the ln 32, since those both have the same base, they cancel each other out, and all we just have is 32. Not a huge surprise. Same thing goes here. We got a base of 10 for the exponent. We got a base of 10 for the log. They cancel each other out, and so we just get 1/2. That is really all there is to it with the inverse properties of logs. We're going to be using those most of the time in equation solving. This is going to be the big reason this is going to exist.